Hello. So in my previous video I solved the 10-pin bowling problem in Clojure. So in short, basically you're writing a program which um, takes a list of all the um, rows formatted like this and calculates the score. So the main complexity of this problem is calculating all the bonuses. Anyway, so how I did it this morning, basically a key decision I had to make is whether I wanted to loop over the individual rows or if I wanted to loop over the frames. So a frame basically means each pair of rows, although a frame can be one in the case of a strike or even three in the case of a final frame. Anyway, so yeah, the way I did it, I was looping over the individual rows, but that meant I needed a couple of extra variables in my loop to keep track of the frames themselves. So what I wanted to do is re-implement this again using a different algorithm and see if it's easier to read, because as you can see this is quite dense. We've got quite a lot going on here. So up here we've got a few functions, so we use this one to pass our rows, so it just filters based on spaces. No, it filters out the spaces and then it just implicitly converts it to a list of characters. So the reason we have n_equiv here is because our input contains x's and forward slashes. So an x is equivalent to 10 because it's a strike, and a forward slash means a spare. So yeah, the purpose of this function is to whether we receive a character, because as I said, our parsing earlier gave us characters. So if we receive a character, we need to at least convert it into a number. If we receive an x, we need to make it a 10 because it's a strike. So this is used just for calculating the bonuses, really. And this is basically an addition function which is clever enough that it can use the this n_equiv function to convert everything. So whenever we do addition, we can just do that and know it will sort it out. The strike bonus and the spare bonus functions just handle those use cases. So as you can see, the strike bonus, it receives as its argument the remainder of the rows that we haven't looked at yet, and it passes out the first two and calculates it based on that. Spare bonus, very similar. And here's the main loop. So as you can see, it's a bit horrendous and a bit of a monster. So as we go through our loop, so we are so this rows variable is initialized to be all of the rows, but as we loop through, each time it recurs, that's going to be chopped down smaller and smaller because it's only the remaining. We keep a running count of the score here. We record what turn we're in here. We need to know what turn we're in because the 10th turn has special rules. T roll, I forget what that even is. So T roll, yeah, so T roll is just for remembering whether we're at a new frame or just carrying on with the existing frame. So if you look at when we recur, so here we got a strike. So basically what we're doing with T roll is 0 means new turn. I should probably comment this. And what did I do? Did I make 1 be that we're continuing with the turn? Yeah. And then F score. So the reason we need this is because of the special case of the spare. So spares are messy. So the problem with a spare, so every spare is the same essentially, because it doesn't matter whether you've got a 3 followed by a 7 or a 5 followed by a 5, the result is always the same. But the problem is the fact that we're looping over the individual rows instead of the frames means that that's difficult to handle, because if we get a 3 followed by a 7, we don't actually know that we got a 7 by looking at the characters one by one, because if you look at how our input is formatted, so when you're looking at it like this, you can see that obviously they got a 9 and then they got a 1. But if you're just looking at it one character at a time, you don't know what you just got, because if you don't have the ability to see what you got previously, so it just creates a messy situation. So we had to just add this extra variable as a kludge for that. So this just records what we got in the last turn. This right here is really the messiest part of this, and it's what I'd like to fix. Yeah, and then we cycle through everything. So this code up here is the special case for the 10th turn, and this lot is all the actual logic for all the other turns. So this is if it's a first roll, this is if it's a second roll, first roll strike, first roll non-strike, etc., etc. Anyway, so I'm going to rewrite it. So we've already got a function that I made, which I haven't used yet, pass frames. So instead of giving us a list of rows, it gives us a list of frames. So we're just going to write a new bowling score function, implementing that algorithm. And we will see if it's better. And we can reuse all the tests that we already wrote. So what's our input? So our input is a string. We're going to copy paste as much as we can, because we're implementing a new algorithm, but we're not. There's no reason to duplicate work. So frames is what's the function called? Pass frames. So do we need to keep track of what frame we're in? There's two ways we can do that. We can either count as we go, or what we could do, so you can do this cool thing with range. I'll demo it actually. You can do this cool thing with map and range. So if we just do, and then we do just demoing how to do this. So if we wanted to make a map, we could do so this would be like frame. Oops, what did I just press? What did I just do? So frame would be A, and then what would it doesn't matter, but the point is, if we do this, so you see what it's done. So the range function is just going to keep spitting out incrementing numbers. So we've got a 0 and a 1 and a 2, and that'll just keep going up and up. although this isn't quite right because we would need to make sure it starts at 1, right? And map will just keep taking them until it's exhausted one of the lists it's given. Anyway, so do we want to do that, or is it unnecessary? It kind of seems unnecessary. We can just do it with the loop. It's fancy and everything, but no, maybe it is tidier. Yeah, it means we don't have to pass as many variables through with our loop. Should we try it like that? No, I'll try it this way first. I'll try it. Let's not do anything adventurous, right? So, right, so f count is the frame count, right? So that starts at 1. Cool, and we keep track of our score, and that should be it. So instead of needing 5 variables going around in our loop, we're hoping we can get away with just these 3. What am I doing? Cool. So the loop starts, and we've got a frame. So what exactly does our frame look like? Let's just test that. So oh yeah, we haven't. Yeah, we need to do the same thing we did before. We need. Don't we need a let? Yeah, so we need a let exactly like this. Oh man, you can just do that, right? Yeah, except for the frames. Frames. Cool. Loop requires an even number of. Yeah, because we haven't. Yeah, I get it. Can you get rid of the highlighting? All right, well, we don't need to print it. The problem is we can't run this because we don't have a control logic. Cool, anyway, so what's going to happen here? Let's add our control logic, right? So how do we, if equals turn 10, yeah, we can do that, like what we did before. Oh, are we calling it turn? Let's call it f count. Did I just press the wrong key binding? We want, right. If the turn is 10, then we just return our score. We just need some control logic just so I can actually start testing it. Otherwise, we do all this and then we just recur. So frames will be rest. F count is off, yeah, so plus F count 1 and score. So that's just increment the score by 1 each time. We're just testing. Why have I done this with my... seem to have a problem with my parentheses today. Cool. Loop requires an... Oh, so have I made just like a mistake here? Oh, yeah. Cool. So, see what happens. Cool. So our frames. Wait. So what are these? So. Oh, they're strings. Is that a good thing? So as I said earlier, so I realized that the special case of the spare is every spare is equivalent. It doesn't matter if you get a 4 and a 6 or a 1 and 9. All spares are the same. So we're going to special case that. So right. So hang on. So we're checking. So we just do an if and we explicitly look at the second character of frame. Yeah, the only question is, do we want to sub? How are we gonna? I mean, what happens, for instance, if we? Because I'm assuming we can't do. I'm assuming we can't do like that. Sometimes I wish it wouldn't give us such. But we can use what's that function called? Yeah, so we can get a character out like that. Yeah, I don't know if that's optimal, but sure. What? So we're getting the second. So the second character of our frame. So is that how it works? No, because 2 gives us the third character, right? Because it's 0 indexed. I'm trying to remember the key bindings here, so we can just do this, can't we? Yeah. So if nth frame, yeah, so if the second equals a /, then we have a spare. So then we just recur right. So we add to our score 10, and again we need so for our previous solution we had these functions which deal with bonuses. We need that again, but it's going to work slightly differently. So the previous spare bonus, yeah, it just takes a list of the upcoming rows. So this is where our new solution is going to be uglier than the old solution, is that because we're not processing it row by row, we're processing it turn by turn. So we're going to need a clever function that can so we'll still give it the rest. We'll still give blah blah blah. We'll still give it rest. No, we can't do that, can we? No, we have to give it... Yes, for spare we can. Is it different? No, it's fine. So we just give it rest. And then it needs to just be clever enough to deal with that. So, for example, because what a spare means is... well, okay, so the time when it gets messy isn't with spares, it's actually with strikes. Because if you get a strike followed by another strike, you actually need to reach across 2 frames to find out what the bonus is. So that's why things get a bit messy here. Right, what we're doing, so what did I call these functions before I called them? So we need strike bonus 2 and spare bonus 2. Let's just copy them and modify them as we wish. Oops. It's important to understand what we're doing here. So, okay, so we get a list of strings. So can you use closure destructuring to actually take apart a string? I've never done that before. That would be interesting. And then we just, well, that looks weird. So if we just call that and give it a wrong number of args 1, yeah. Oh, I forget how. Yes, we can do that. Okay. You know, some people don't like destructuring. They find it hard to read. But it's a feature Clojure has, and I don't have anything against it. Right, so we receive our list of strings. It still hurts my brain though. Yeah, because my test down here, I wasn't giving it a list of strings, I was giving it a string. If we give it a list of strings, then we're going to need we would need no, we can't do AB, can we? Because we don't even know how many so this is next frame. So this is everything inside of next frame. Wait, no, this breaks over. Yeah, obviously. Yeah, so this right here is going to be the hardest problem of solving it like this. So what we're going to need to be doing is a sort of flattening operation, right? So let's do a recap on what our data structure is. So we're receiving what? We're receiving, what is it, a list of strings, right? A list of strings. How do I know that? No, I think it's a list of strings. I don't remember how I know that, but that's what I wrote. Yes, a list of strings, right? So we're receiving a list of strings. So yeah, we need to flatten it all together somehow. So how do you flatten data structures in Clojure? I don't know. So to be clear, we've effectively got a list of lists, and we need to flatten it so it's just a list. Actually, I might know how to do this. We use apply, don't we? So if this is effectively a list of lists, because a string is a list of characters. Where's my water? I'm going to just find my water. Right, so as I was saying, so can we use apply to can we use apply to, hang on, so we're applying what to what? So what happens if we do that? I hate the way it handles these errors. Like, do I need to get this pop-up? The pop-up is never helpful. I need to turn that off. Yeah, so sequence can't take multiple arguments. We need to do the opposite of apply. I feel like I should know how to do this. No, we just apply them to concat, don't we? Yes, there we go. So that's how we flatten it. Cool. So, wait, what are we doing? So we're doing spare bonus, right? So what we've done is we've basically converted a list of frames into a list of rows by flattening the data structure, or what we're going to do anyway. I don't know what's the most efficient way to delete. Cool. So okay, so we have a list of So all we do is just return the first item, right? That should be pretty easy. Cool. We better check it works. So what we think we're giving it is a list of strings, right? So the list of strings could be like 46, X. Yeah, so our bonus is just 4. Yes, no, we're missing something. Because our bonus needs to be converted. Because we've got that function we made ages ago, right? n-equiv. Are we not? Where's our spare? Yeah. So that's what we did for our spare bonus. We just ran an n-equiv on it. Okay, that should do it. Cool. All right. It's supposed to fix the indentation. Right, there we go. Yeah, so that was pretty easy. That might even seem overkill for what we've done, but why? I'm sure when I wrote this, it wasn't overflowing the. Is it because our line numbers have gotten into? I don't know what's going on. Okay, it doesn't matter. Anyway, the strike bonus is where things really get complicated. Oh. What do they call them? Frames. We're just explaining the important part. For strike bonus, we can still. I think that's it, isn't it? So if we get another spare, we add a 10. I think this is it. Cool. All right, so we've got our spare bonus. Well, I mean, we ought to at least test this. Oh, I didn't evaluate it, right? This is invalid anyway, because it's not going to be 46, is it? It will be. Cool. So if it was an X and an X, it should be 20, yeah? And if it was a 3 and a 2, it should be just... Yeah, cool. That seems correct. Cool. If we could be asked to do things properly, we'd make tests just for these specific functions, but I don't want this video to be too long. Right, so spare, so so we're adding 10 with spare bonus 2, processing, processing rest. Cool. Cool. So yeah, that seems right to me. Yeah, so that's it. We've processed what happens when we get a spare. Cool. So what happens when we don't get a spare? So I mean that's oh. So we need to do case, right? So because a strike is a special case also. We need to do a cond. Right. Wait, why do we just randomly have? That's not valid. We can do that, right? That's cool. So if it's an X, can I do that? Strike. This is hideous. Why is the formatting like this? If we the formatting is hideous. But hang on, let's at least then. Oops. Cool. So we've got a strike. So we've got a strike. So this is another special case. So yeah, we can just immediately call recur. I know the 10th turn is different, but we're going to deal with that later. F count, frame count, right? So yeah. Add to the score 10. So yeah, it's just a strike bonus instead of spare bonus. Strike bonus. Yeah, that seems correct to me. So now we need the case where it's neither a spare nor a strike. How do you do it? It's else, is it? I did this earlier. Yeah, it's just else. Else. So this is the normal case. And we're going to do what? We're going to, yeah, we just recur immediately again. It's just that so our score is, instead of adding we're adding what we're adding. we just need to pre-process. No, wait, no we don't. No, it's already clever enough to do that. Apply ++ to what? To everything in the frame. Everything in the frame. Yeah, so that should work. Let's just check that. So this should be 5, right? Yeah, cool, so that works. So what's this at the bottom? So this is just, I put that earlier just to make the function work, right? So we can delete that. Cool, so what do we have? Can we search upward in our... Cool, so what happens if we do that? Oh, we've still got... Wait, we haven't reloaded our buffer, have we? Oh. So line 1. String index out of bounds, okay. Sorry, what is it this? Well, yeah, because we might not be able to check that because okay. So, is it are the conditions in cond checked in order? So presumably, what happened? Yeah, it got to that one and then it errored, right? It makes perfect sense. So, is cond guaranteed to check everything in the order you give it? It evaluates each test one at a time. Yeah, so I think it's reasonable to assume it's going to evaluate them in order. So simply by reordering these, we can get rid of that error. Cool. Obviously, the score won't be right because we haven't implemented our special case for the last turn, but yeah, this is definitely looking a lot tidier so far. Cool. So all we need to do is implement our special case for the 10th turn. Can we just do it the same way we did it before? If equal turn 10, is that exactly what I've done? Yeah, so we've called it F count, but can I copy paste that? Well, we haven't. Well, we need to put this inside of here, don't we? Otherwise, because it's not rows, it's frame. How do you fix this? Because what we need to do is essentially transpose. We need to move this let up to a higher level. Does Paradit provide a way to do that? To literally invert the ordering? Well, maybe it does, maybe it doesn't, but I don't know. So, what the, stop it. Right, so the yellow matches up to the yellow, right? So around all this, we just put a let, and then we just right, so second frame. So frame, so what's frame? So frame is a list of characters, right? Yeah, so rows, so what? Is rows what? Hang on. Yeah, everywhere that we've used rows previously, it just becomes frame. Because frame is a list of rows for this frame. And it's the last frame, so it's everything. Cool, so in theory that might do it. 99, I think that's even correct. Imagine if it's really that simple. So let's try this this test. Wait. What the hell? I've written the test wrong, but it seems to work nonetheless. How odd. So this is supposed to be, yeah, we get 300. So cool, so let's run our full batch of tests. What are we going to do? Just rename. Oh, well, that would be irritating. Cool. So that's, oops, let's see. Oh yeah. Oh. Yeah. So everything failed. But I can't believe that because I just tested. What on earth? Was this 99? Have I just broken the tests or what? I don't understand. 99? Why is it comparing everything against 99? Okay, I don't even understand what's happening. I'm sure the output of this is not 99. What's even happening? What the hell? I renamed the functions, right? Has that somehow broken it? What's going on? So when it was called bowling scored 2, it was working. But then when I renamed it to bowling score, it stopped working. Listen, that's the correct result for... What on earth is happening? Sorry, what? I don't even understand what's happening. There's no way that that's 99. How could it be? Okay, let's rename everything bag. I don't know how renaming things breaks it, but okay. So when we do bowling score 2, okay. But why would that be 99? What a weird coincidence. We were testing it earlier. What the hell is going on? Look, I can't believe that is returning a result of 99. Let me scroll back up. What did we get when we were testing this earlier? So we got 84 and then we got 99 and then we tested this. Oh, but I was using the wrong... But why 99? Going under the assumption that there is actually something wrong with my code, but why is it always returning 99? Wait, where's... Oh, for crying out loud. I want to test it with this case. Okay, so there's something wrong with my function wherein it always returns 99. Very, very odd. I mean, the outcome is independent of the input. I mean, what happens if we give it... What on earth is going on? That's just bizarre. So it doesn't matter what input we give it, it always returns 99, which is coincidentally the correct result for this. What the hell? Okay, I'm going to close and restart Emacs because I suspect that something weird is happening with the development environment. I can't imagine how my code could just coincidentally have given the right result to the first problem. But it actually just always returns 99. What would be the probability of that? So do we still have our history now? Oh, because I didn't load it. So honestly, it's just such a bizarre... So our code always returns 99 no matter what. I can't even imagine how that could happen. Doesn't that just seem infeasibly weird? Not least because that is actually the correct answer to the first test I put in. What on earth is going on? Okay, so at what point do we actually return the score? So all of this code is our special case for our 10th term. I don't even know how to debug this. This is bizarre. Well, we're just going to have to check everything one step at a time. I mean, so what's frames? Are we successfully passing our frames? Yes. No, we're not. How did that happen? What? Where does this come from? What the hell did I do? Huh. So this... Well, that completely explains it then. My parse frames function, I simply forgot to remove the test data that I'd put into it. So I've just hard-coded the input, which just by coincidence was the first. That's hilarious. Okay. Right. So now we should stop getting bizarre answers. Okay, now let's rename them as we did before. So bowling score -old and bowling score. Oops. Cool. Oh yeah, we've got all that noise in the... I think it passed the test mode, and let's remove the debugging nonsense. Not equal... How did my test become wrong? Bizarre. Cool, so it passes the tests. Just out of paranoia, because I've done so much messing around. Let's just check that we are actually testing the right thing. Cool. Wait, I did load it in right. I think I must be a bit tired. Cool. Success. So we've re-implemented the algorithm. So, okay, so this is the new algorithm. So it's just less than 1 page. And the old algorithm was just more than 1 page. Yeah. A thing to commonly do is check performance, but I suspect the performance will be so similar it makes no difference, but just for curiosity. Let's test. Okay, hold on. Let's use this one, right? Cool. Why? Cool, so time 0.48 milliseconds. Yeah, the time is always fast to the second. Oh look, it's extremely variable. It can take anywhere between 0.1 millisecond up to an entire 1.1 millisecond. Yeah, I mean, I think they're both going to be so fast that there's no no point even comparing performance, to be honest. 0.4 milliseconds. Oops. Yeah, they're both extremely fast. There's no noticeable performance difference. But no, I think the new algorithm is slightly better. It took me less time to write it, although obviously I was reusing some stuff. Yeah, I think it's a nicer algorithm. The code is slightly smaller. I think it's easier to understand. So yes, I think that is how you solve the 10-pin bowling problem the right way. Yeah. Alright, I guess that's the end of the video. Goodbye.